Welcome back, folks. We're still trying to validate our assumption that a BJT is in the active region. I showed you one way how to do it in the previous video. I'm going to show you the second way to do it in this video. I like this method because it's less ambiguous. You can pretty well see whether it's in either the active, saturation, or cutoff regions. I also like it because it kind of gets to the heart of the matter of what a transistor is doing in the circuit. It's a switch. It can be on, it can be off, or it can be somewhere in the middle. And we're going to use that to try to go figure out whether our active region assumption was true. Okay, so I still have the problem here. I put it on a fresh sheet of virtual paper. And let's take a look at that. So here's the circuit that we've been playing with, and we found our node voltages. Okay, we found our node voltages as 5, 0.7, and 3.5. And what we're going to do here is consider what's happening with the voltage from the collector to the emitter. Okay, so let's go do that. Let's find, how did I have red? Who wants red? Find VCE. Okay, and again, that's as simple as saying, well, VCE is equal to VC minus VE, and the emitter's grounded in this circuit. So this is just going to be 3.5 volts minus 0 volts. Okay, so VCE is also 3.5 volts. Now the question is, what does that tell us about the state of the transistor? Well, the voltage across a short is known, right? Voltage across a short, okay, is 0 volts. Okay, and I don't want you to think of it as a short. I want you to think of it as a saturated BJT. Okay, when I did like a few videos ago when I said it's on, it's off, it's somewhere in the middle. When it's on, we call it saturated, and we treat it as a short circuit. Okay, well, from C to E is that short circuit, and the voltage is going to be 0 volts. So I can see that this is not anywhere near 0 volts. So I'm going to say, hey, it's not saturated. Okay, now the open circuit, when we go into cutoff, is a little different. We got to think of this a little differently. So if we're in cutoff, let's think about this circuit in a different way. Okay, we had that 5 volts out here. Okay, connected to an 86K RB. Okay, and then we had a diode here, but if we're in cutoff, we're really treating that as an open. Okay, so there's no current flowing there. And then we had the 150 over here, right? And again, if we're in cutoff, we're treating this as an open where the collector was connected and where the emitter is connected. Okay, so that's VCE right there. Okay, so in cutoff, let's get a different color so it pops a little. Cutoff. Okay, we're treating it as an open circuit. And that open circuit is between the collector and the emitter. Okay, so in this case, in cutoff, what is the voltage between the collector and emitter going to look like? And we can figure that out by writing a KVL that crosses over VCE. Okay, and we'll come back over here, and that's our KVL. There's no current flowing through that 150. It's only connected on one side. So that's not dropping any voltage. So we can say we go up 5, we go down 0 volts, and we go down VCE, and that's equal to 0. Okay, so VCE is equal to 5 volts, and this is true when in cutoff. Okay, so in saturation we expect it to be 0. in cutoff, we expect it to be 5, and we got something in between. Okay, so we're saying VCE, that's a horrible E. There we go. VCE is, well, it's greater than 0 and it's less than 5, so therefore we are in the active region. Therefore active. Okay, I like this one. All I got to do is find the voltage at the collector and the voltage at the emitter, and maybe this cutoff voltage is important to find as well, but I can pretty quickly tell you whether it's in the right range, and like I said, it's either going to be shorted, it's going to be open, or it's going to be somewhere in the middle. And when we're somewhere in the middle, we're in the active range. Okay, so I think it helps with the intuition about a BJT and how it's working. I hope that helps. I think, where are we going to go from here? I'm excited, right? I think I gotta mess it up. I think I gotta move us out of the active region because, well, that's going to happen a lot. Okay, so let's look at an example of a circuit that has that's operating in a different region in the next video. I'm excited. I hope you are. Stay tuned and good luck, folks.